So let's talk about what's a picture of. We need to practice these cylindrical coordinates. So to get comfortable, let's draw rho equals 1. So what are all the points in three-dimensional space that satisfy the property that the rho coordinate in spherical coordinates would equal 1? Now remember that rho is the straight line distance from the origin. So we're talking about all points that are exactly 1 unit away from the origin. Right? So we can draw a picture, and it should be a sphere. Right? There's the equator drawn, and there's the top half and the bottom half. That's my attempt anyway, just to put some words to it to make sure it's clear. This is the unit sphere centered at the origin. Now, let's draw rho equals 3. Okay, well, all the points that are distance 3 away from the origin. So I'd say you get something that there's the equator part, and then there's the top half of the sphere, and there's the bottom half. So this is a sphere of radius 3. Let's do another. How about let's draw rho is equal to 0. Okay, all the points, remember rho represents the distance that a point is away from the origin, like the straight line distance. All the points that are a distance of 0 away from the origin, well, that's going to be just the origin itself, right? So that's just the origin. If you want to use words like sphere of radius 0, I guess you can do that as well. Now, let's talk about there's one more spherical coordinate. So what is phi? Okay, what is phi? So just quick punchline matter is that phi will be between 0 and pi radians. And yeah, well, phi is an angle. Phi is, in fact, the angle. Phi is the angle made with the positive z-axis. Okay, what do I mean by this? A picture, I think, is very important to draw here. So there's an x-axis, say there's the y-axis, and say here's the z-axis. And then we're going to just pick a point. Doesn't matter what the point is, so somewhere x, somewhere y, somewhere z, wherever. You just have a point somewhere in three-dimensional space. Okay? Maybe I'll draw the point higher, actually. Okay, so I got my point P. Now this point has, x may be 2 and y might be 8 and z might be 12 or whatever. But the thing is, this point I'm going to connect using a line segment, which is directly from the origin to that point. Okay, straight line. Then this line segment, together with the positive z-axis, creates an angle. Okay, so the angle between these two here, whatever angle is created, that's phi. Okay, so let's do the following. Let's draw a picture of phi is equal to pi over 30. Okay, so remember that phi always has to be between 0 and pi. So what points satisfy the property where the spherical coordinate phi is equal to pi over 30? Well, that means that this angle here, pi over 30 I picked because 30 is rather a big number in the denominator. So pi over 30 overall is a very tiny angle. Yeah, so the picture of all the points that satisfy this property would look something like this. It should be a cone. Let me actually accentuate this a little more. The points that we should get should be a cone. A shape that looks like that. But the thing is about this cone, it is a very thin cone, meaning down here at the point, this is a very sharp corner. Okay, so the thing is, any point that's part of this cone, if you draw a straight line from the origin up to where a point is, the angle from there to the z-axis is very, very tiny. Now, let's draw a picture of phi is equal to 14 pi over 30. Now, I've picked the number 14 pi over 30 because this is a little less than pi over 2. Okay, so let's get some axes in here. X, Y, Z. Now the angle should be created by a point, a point, you take any point, and when do we include a point? When you connect that point to the origin, and that line segment forms an angle with the positive z-axis, and that angle should be just a little less than pi over 2. So what should that look like? Well, it should be a cone, again. But now the thing with this cone is, let's try that a little better here. The thing about this cone is that let's see if I can try to really draw a circle there, and then the back part of it here. This is a very wide cone now. Okay? So, this angle formed by the positive z-axis and then, any point that's on the cone, it should be rather large, very close to pi over 2, right? So the thing is, this cone that's up here, it's so narrow. I mean, eventually when you go out further, it gets bigger, of course, but just relative to being near the sharp corner, this is so narrow, it's not going to fit a lot of ice cream in here. If you're going to get a cone at all that you want a lot of ice cream in, take a look at this cone down here, right? You can fit a lot of ice cream in this. In fact, it's barely a cone. The corner here is not very sharp. Not so sharp. In fact, the picture itself here, 14 pi over 30, it's probably not even a great picture of this because it should be so not sharp that it's almost flat. In fact, this shape is almost just completely flat, like a plate or something like this. Okay, let's draw phi is equal to pi over 2. It's important to really do what we can to understand what these pictures look like so we have a very, very good understanding of spherical coordinates. So what's this going to look like? So all the points where when you pick a point, you draw the line segment connecting that point to the origin, and then you also look at the other line segment, which is this line segment, the positive z-axis. The angle created needs to be pi over 2, or in other words, 90 degrees. Well, sorry for how I'm shading this. I don't know if that's clear enough, but this should be exactly the xy plane. Any point on the xy plane, if you connect it to the origin, the angle formed by that line segment and the positive z-axis will be exactly 90 degrees. Let's do another one. Let's draw phi is equal to 29 pi over 30. What do you think that looks like? Well, we should think about how, okay, let's get some axes here. Now, you would include a point if the line segment connecting that point and the origin versus the positive z-axis creates this angle that's very close to pi. Remember, pi is the largest possible value for phi. So what happens when that angle is slightly less than pi? It should create a cone that's very thin again, but it's just upside down from the cone that we drew earlier. Otherwise, it's exactly the same cone, just upside down. Now, what I'm trying to get at, just so we really understand where this angle is appearing in the picture, you pick any point on the cone. A very convenient point to draw on the cone is like a point like right there. Then that point, connect that point to the origin by a straight line segment, and then look at the positive z-axis. The angle created between these two is very close to pi radians. Let's try another one. How about we draw phi is equal to 0. 0 radians. Okay, so we want to talk about now all the points where if you take that point, we'll include a point if, when you connect that point to the origin, that line segment drawn creates an angle of 0 radians together with the positive z-axis. So what points are going to satisfy that? It's going to be the positive z-axis itself, right? So it should just be the positive z-axis. Okay, let's do another. Got to really practice and understand these spherical coordinates. There's a lot of geometry going on, and that is really key to understand. So let's draw phi is equal to pi radians. Okay, so we would include a point. Again, think of using this language yourself to understand what's going on. You would include a point if, when that point, you end up drawing from that point to the origin with a straight line segment. And then that line segment, together with the positive z-axis, together creates an angle of pi. So which points are going to do that? That should be all down here, right? That should be the negative z-axis.